Welcome to This Old App, a podcast about learning, coding, smashing stuff together, breaking things apart, startups, failing, winning, and any other buzzwords we can think of.
Hey, Don. This week, let's talk about relational databases versus document databases.
All right, so useful versus non-useful. Got it.
We're going to be positive about all technologies presented until the end, when we have proven that one of them doesn't make any sense.
Well, I'm excited. Let's talk about all the positives.
Well, I probably need to go on MongoDB and see how they sell document data stores. I mean, first let's rewind and say out loud what the heck we're talking about. So on one side, we've got relational databases. They've been around for a long time. That was the first thing I used. The first database I ever used was Lotus 123. It was just a spreadsheet with rows.
Right. Not really a database, but yeah.
By the definition of a persistence layer, data store, it's a mechanism to store things and persist it. So I always...
All right, I'll let you go with it.
And I always tell that to my students, so don't argue with me on that. But then you take... The next step for me was Microsoft Access. And that was essentially the ability to take a lot of these Excel tables and link them together, associate them with relationships between them, foreign keys, primary keys. And I actually got a lot done with Microsoft Access until we would hit the limits. Microsoft would always put a governor on them because they didn't want people using it as production because it was cheap. But I was with a company for a decade that was in the millions of dollars, and they had a system built on Access, and they kept using it. And every year, we would delete all the stuff, all the records and migrate it to other formats for auditing. And we just kept using Access until they finally moved off of it late in my time there. So then, otherwise, I've used SQL Server. That's Microsoft's enterprise level relational database. In the open source world, I used MySQL. I think we both used MySQL. That was the backend for Drupal for the most part.
Right.
Postgres is what I have moved to mainly because of the work in Heroku, and Rails community is really strong with that. But, I feel like my entire career on the data layer, on the persistence layer, has always involved relational databases for the most part. And then in the last 5 to 6 years, as JavaScript became more predominant and JSON became like the payload sent over the wire format instead of XML, we got data stores that store data as objects or as like what looks like a JSON format or JavaScript object.
Sure.
And so I've resisted it for a long time, even looking at them, because I didn't need them. Like I just had no reason to switch away from relational because I just wasn't ever saying to myself, is there a better way to do this? Because once you learn structured query language, SQL, the mechanism to do CRUD, create, read, update, delete, you have a tremendous amount of control with a SQL-based relational database.
For sure.
I guess the biggest issue with relational databases may be scale. They may cap out at a number that I'm not aware of myself, but I know that eventually people using relational databases have to do something called sharding, SHARD, splitting the databases so that the capacity and indexes and whatever, what have you, is more efficient because you've capped out on what it takes to store, backup, and query one of these databases. There's so much data in it, apparently.
Right.
I've been very fortunate. Well, I guess I should say I haven't run into the problem of needing to mess with that way, like mess with scaling that way. We've usually found that a lot of the excess of data was not necessary to keep. And so we didn't need to shard a database. But that may be like most of the businesses I've worked with that did well with the product we built them, volume wasn't their key. Volume of data wasn't an indicator of their success. Because they had big ticket items they were selling or something. If you get into like retail at a level of Amazon or something, you're talking about millions of transactions a day maybe or something, or at least a week. So that's when you start to hit those barriers. The other area I think you hit, you have two different types of uses for a data store, maybe. You have transactional and analytical, I guess. And transactional being like, hey, users are creating orders and submitting new items to the database, and it's allowing business to get done. And you model your data, your tables and your data in a way that makes it efficient for transactions to be recorded and executed. And then on the other side is after you've collected all that data, you want to analyze it. You want to look at it, processing the numbers, critiquing it. I don't know, like any number of ways that you will analyze, observe, and extract data, derivative data from what was a collection of the transactional data.
Right.
And I think you've done more of that than I have. I've done a little bit of it, but I didn't really have to change. I changed a little bit. I did denormalize, or I took the relational structure of mini tables and put them into one to eliminate the joins, which were slowing down some analytical queries.
Right.
But so I guess I have messed with it that way. So all of that's being said, that's on the relational side.
Well, I'm gonna stop here for a second because I like digging into this stuff. So how old do you think relational databases are? When do you think they were invented, and when do you think they actually came into normalized use?
If I started using them 20 years ago, and I would give them about 10 years of use before that, most likely, which means they were theoretical for about 10 to 15 years before that.
Right.
My guess is you could go back about 40 to 50 of use in my mind.
Yeah. So it looks like the theoretical started in the 70s. That's when they started to develop it. IBM developed something called System R, which was essentially the prototype. And it first commercially, the first commercial database was Oracle in 79. So I looked at that because I actually, when I was in college, I remember the big, thick, burgundy leather-bound our relational database textbook that we got. And so that was 89, 90. I assumed they'd been around forever. And here it is, they'd only been around 10 years.
Yeah.
So it kind of surprised me that they're actually that young. But yeah, no, I digressed for a minute, but looking at the rankings, they're really at the very top are all the relational databases, right? Oracle, MySQL, and Microsoft SQL Server. And Enterprise is Oracle and Microsoft, with MySQL taking up all the hobby layer, hobby plus layer, I'll say.
Yeah.
And now to transition to what you were saying about performance and scalability. At Aspire EDU, it's something we're working on right now. We're working on continuing to make our database smaller and smaller to improve performance, because we've got it set into a couple different ones, but they're still very large databases. So writes take a while, reads take a little bit, and we're pushing some boundaries on the size we've got in there. So if we're able to scale it down, we are gonna get some performance improvements, and B, we think the cost will go down a bit. Even though we'll have more actual databases, they're going to be smaller and require less memory. So we think we're gonna get some cost savings there as well. I wanted to dive just a little bit into that RDBMS history a little before we got into document store databases.
So I was always bumping on the edge of document databases just because they were the new flavor of the day, and you could hear the hype train coming down the track. And no matter what I did, when I would look at starting it, I just remember thinking, it's interesting to store your data just as like you're sending it over the wire. Because whenever you use Rails, like let's say you're using Rails and you're using Postgres SQL in the back, when you send over, like if you hit that API, you're sending the data in a JSON format, which is how it looks like it's stored on Mongo. And so I think that there was like this, people got this idea that it's better to store your data just as like you transport it. And maybe it was more understandable to folks learning JavaScript and JSON and APIs is like, hey, you get to store your data that way too.
Right.
But what I guess I'm at a loss for, and now let's go, I'll keep going on what document data stores are. So now the ones that I know about, you have Mongo as probably the main commercial open source database for document data stores that I am aware of. You also have Google, which started out with real-time database, which really was just a JSON object of sorts. And then they also said, hey, this is worse than a document data store. We're going to create Google Firestore, which will actually work just like Mongo does with documents and collections and shallow queries and the ability to more easily create indexes, which I'll get into later. But then there's also, I think, Amazon Dynamo. Is that their version?
Yeah, Dynamo DB, which they actually describe as both a document store and a key value store. So you can go either way on it, and key value store being one level of complexity even further down to where all you're storing is a key and a value, no depth there.
Yeah.
Which is kind of like Redis.
Yeah, that's Redis. This is in my world. Or in every world, but as I've known it. And then like there's other ones out there. I know CouchDB is what people use on mobile devices a lot. PouchDB is another. There's a lot of different ones.
Couchbase is actually the next largest. So as far as document stores go, Mongo's the largest by a good margin. And then you get Dynamo DB and then Couchbase, and then you start getting to where the numbers don't matter.
So I didn't really mess with that stuff too much until I ended up teaching that class, the boot camp last year, where we were teaching Firebase, which I had barely flirted with by that point, and MongoDB. We taught all three. We taught three different data stores: Firebase, real-time database, MySQL, and Mongo.
Right.
And then a number of the tutorial folks that I watch, some of them started using Mongo and some of their examples, and I kind of just played along and built whatever they were building.
Right.
And I gotta say, I still don't get it. I don't. Maybe if the answer is sharding is easier, scaling is easier, then I can understand that. That is worth a lot to a lot of people. But I don't understand. Like, I never have needed one of the key sales pitches is you could have flexible documents, meaning you could have a person with a first name and a middle name and a last name and then on another user document, it would just be first name and last name. Or if it's like Morrissey or Seal, they just have name. So you can have this flexibility where the keys change and one document isn't the same as the next, which to me is actually horrible in the way I've seen it. But I mean, I've seen bastardized tables with
let me jump.
The Drupal node is an example, but
yeah, sure. Let me jump in there real quick because I'm going to try and play devil's advocate just a little.
That's fine.
Because I think I think this is the blind leading the blind here when we're talking about document store.
Yeah.
But so your example was actually really good. In a relational database, you would have first name, last name, first name, middle name, last name, maybe spoken name or preferred name.
Yeah.
And so you would fill all that out, and then you come across somebody like Seal or Morrissey, which they have full names. Okay, but you may not know it. So your database probably has required fields of first and last name in order to be unique, right? But now you don't know it, so now you're having to go Seal, and then for the last name, you're putting no last name.
Yeah.
And you're bastardizing it that way, as you said. Whereas with a document store, you can do exactly what you said. You have first name, last name. You have someone that just says name, and then you let your code deal with it.
Okay, but so what? But I'm gonna jump in here. So what? Like, does a null value matter?
But it does, because if your code sits here and says, does it have a first name and a last name? Yes, great. Okay, we'll go down this logic path to fill out the form or whatever. Yeah. Oh, it doesn't have first name, last name. It just has name. Okay, we can take that as well, and we'll just put it in that same display area. So it's the data. The point I was going to try and make is the data is better described with a document store than with a relational database. When you look at the data, you go, okay, I know what's going on here. When you look at a relational database and you do those bastardizations we're talking about, you're all of a sudden going, okay, I think I see why they did that, but okay, that's a pain in the neck. Now I got to deal with it. So if I'm going to try and be positive about document store, that's one way of thinking about it, is the data is properly described. And so anybody looking at it can deal with it.
By the way, if you say Seal's real name, you can't listen to anything but Kissed by a Rose for the next 24 hours, which is the worst song I think I've ever had stuck in my ears.
Uh-oh, there go all our Seal fans.
No, I liked his first album. It was just that was a turning point where I couldn't listen to him anymore. But anyway, I mean, I guess I can understand how you might feel that's better, but I don't. I mean, I've dealt with usernames and the very weird variations of them, especially when we were doing the fantasy stuff, fantasy sports.
Oh, for sure.
And there's nothing like athlete names, especially in baseball, that just throws you for a loop. And also when Japanese players are mixed into that too. So I just wonder. I don't understand. I didn't know the pain points that people were having that said, "Oh, I want a document store because of this problem," because I just didn't feel it was a problem. Now, what I was saying before we discussed what you were saying was in Drupal, we had this concept of a node. It was basically the content table for the Drupal content management system. And if you created custom content types, so you went from starting with a blog and then you decided to add, let's say people, you would have like the blog data on a column, title, body, published date, whatever, author. And then you would also have first name, last name, date of birth, age, because you just kept making this content table bigger and bigger.
Right.
Now, if you built a content management system and really felt like you need to put every type of content in the same document or same table, that's when this Mongo document thing starts to make more sense, because you're going to have complete content types that have widely different data. And the description,
and it can grow and shrink without any real issues, and you're not hitting hard walls that you can't go up against. Yeah, the flexibility makes sense. I think that's one of the major advantages, and supposedly the performance. But I don't even necessarily agree with performance.
But then when it came to building anything I did in Rails and probably Laravel now and Node, and you come upon the concept of models, and every content type basically has a kind of what we call a model that helps to manage the persistent side of that content type. So you now have a person, right, a blog, like a post, an order, a grade, if like all sorts of, like, you no longer merge it all together. Drupal is doing that because they were building this content management system that was trying to be the single source of all content that a website would need. But once you get outside of that world, you never do it that way. Like you segment your tables and you segment your documents to represent the real life data that you're trying to store. So that's one selling point people talk about. I don't find it to be worth it. Like, I don't see a reason not to use Relational for that purpose, personally. What I started the other thing that people talk about is the sharding, the splitting of the document. It's easier to shard, and I just don't know if it is or not. I don't know, have you ever sharded a database?
Yeah, we're in the middle of it, and it's not easy. Yeah. It's not for the faint of heart. And I guess what they're saying is that with a document store, it's really just you slice it up and you go. Whereas with a relational database, you got to move everything at once, or else you're having to cross shards in order to find all the related data. So, and that's not
a question I've had I know that sharding is hard if you are using auto increment IDs, because you can get into this area where you split the database, the table, and then you've got 1, 2, 3, 4, 5 on this side, and then starting at 1,000 on the other side. But then both of these tables may grow, and it doesn't know what to auto increment on. So the last 5 years, I've never used auto incrementing IDs on relational databases because it seemed like a UUID, a completely unique identifier that is almost rare to ever be duplicated in the same app, seemed like it would protect from that complexity. So my question to you is, do you think that's one of the biggest parts of sharding difficulty is auto increment IDs?
It's a problem, but really, I think part of it is also the cross-node transactions. Mm-hmm. So if you've got a database with 20 tables, you've got to, when you do the sharding, you've got to try and pull all that related data into the similar nodes, or you've lost all the benefits of sharding. Mm-hmm. Like for what we do for Aspire EDU, there's not a whole lot of if any, and now that I say that, there's actually none, database that one client would use and another client would use the same data. It's all pretty firewalled away as far as this client needs these rows from this table and so on and so forth. So when you're doing the sharding, you got to pull all those rows out and put them all in the same node. That's really one of the major complications.
Right. When you shard, are you putting an index on the front of both of the databases then, so that a request knows which one to hit?
You have to put some sort of shard key management in there. Yes.
Okay. That's what I was thinking.
So it's certainly part of it. And again, that's another level of complexity. So really the direction we're going is we're actually going to go a step further than sharding, which is to create different databases for each client. So there will actually not be any cross node transactions because there's no need for it. So that gives us, it actually gives our clients better peace of mind. It doesn't get it. I'm not concerned about client A being able to see client B's data because there's just no way there.
Yeah.
But it gives clients better peace of mind to say, nope, your data is all in a separate database. No need to worry about it.
No commingling.
No commingling. So that's essentially where I see the difficulty in sharding. Whereas in a document store, like I said, you say, okay, first 200 documents, you go over here. Next 200, you go over here, and go from there. But the difficulty there is you've now taken all the, and I may be taking us a direction we don't want to go yet. The reason it's so easy is that all the logic to actually process it is in your code. It's not up in the database. So we won't go there just yet because I don't think we're there yet. But
so the next item would be speed. And I get massive performance out of Postgres, and I always got great performance out of MySQL and SQL Server. Microsoft Access, no, they had the governor on it, but every time I've ever had to get in a scenario where, hey, the database is really slow, I would go in and find lack of indexes, crappy ORMs that were inefficient on what they were translating the SQL commands into, or poorly structured, or like excessive joins, excessive N+1 queries, too much data being requested when you only needed a small chunk. Like every time a performance issue came up on hitting the database and getting the data back or read and writes was always a matter of poor architecture.
Right.
And sometimes it was me, and I was like, oh, I should have done this better. And sometimes it was somebody else, but you build it a certain way and then you learn, like, you don't pre-optimize. So it wasn't anyone's fault. Usually it's just like, oh, you didn't need to store every single event on a table that is now 15 million rows and is indexed so heavily that a read write for an event on a browser is taking 15 seconds to write. Right.
But I guess document store advocates would say, but you had to spend time to do that. Mm-hmm. And they don't feel you need to optimize as well as much with a document store. You can get away with a bit more. There is performance implications using an RDBMS. I don't think that's a question. I also don't think that the implications are significant enough to override all the positives that an RDBMS gives you over a document store.
Yeah. Here's some of the weirdness now is related to querying, like the way you query and this is going with Firestore. I don't know about Mongo, but I think Mongo is similar. Let's say let's say you've got a table and it's got a person's name and their age. On Firestore, if you wanted to do a query that said, hey, give me everyone with the last name Vandemark that is under the age of 30, they actually create on real-time database, you actually have to manually create this weird join table that would take the last name underscore with the age. And then you have to maintain that. Like you have to actually keep up if the age changes, you have to go in and also update this weird join index thing you wrote.
Right.
So that you can then sort it by random. Like you have to do your query so that you're looking at that index thing instead. Now the Firestore is nice because if you decide you want to do that query, you just tell Firestore, hey, I'm going to do a query that includes these two values, and they create and maintain the index for you, this new index row. But it's still ugly as sin. Like
right.
The type of queries I ever have to do with relational is I just have to figure out what is the SQL command for this. Not I need to create basically a new key value that tracks these two things together.
And what you just did was a very simple join.
Yeah.
When you have relational databases, you've written them, I've written them. There are some very significant queries you write, and those just aren't possible in document stores. The best advice I won't say best advice. The advice I've seen is pull all the data you need, and then in your code, go ahead and slice it up the way you need it, which it goes away from everything that as relational database programmers we've been taught. So maybe if you grow up in that world and you're educated in that world, it makes a little more sense. But the database engine itself is optimized to do those queries. So I feel fairly confident I can write an SQL query and it'll execute faster than a JavaScript code that's parsing all the data that I pulled from this document store. Now, you mentioned a couple different ones. You mentioned Mongo, which I'm going to put out here by itself. and then Firebase, Firestore, Dynamo DB. From what I've seen working with the two different types, there's a lot richer language surrounding Mongo.
Yeah.
And there is surrounding the others. I don't think it's maturity. I think it's intentional. And I think it has to do with the way that Amazon, Google, et cetera, are optimizing where they're storing the data. They can only allow you to do so much, or else they can't optimize. Yeah, to me, it's like, okay, sense. Why would I even? It comes down to your performance has to be so significantly better, and my data has to be so simple that even makes sense.
So then, in that case, the true benefit that I could see with Firestore or Dynamo is scaling, like the sheer volume. They both talk about you don't have to ever worry about giving us too much. Like we will automatically take care of that for you. And so you're really talking about a data model or data architecture that is lacking any kind of like big segmented objects in our models. You're really just kind of putting into one big chunk.
And I think you've hit the difference. Okay. If your data needs are, I need 5 fields. That's all I need. I don't need really deep data. I don't need 5 levels of complexity in my data. I just need 5 fields, but I need 1 billion of them.
Yeah.
Okay. I get it. So a document store might make sense in that case. But that sounds like a very specialized use case. So I do think relational databases are overused sometimes when there's a simpler answer. But what I don't hear enough of, and maybe we're starting to hear more now, what I don't hear enough of is, you know what? No SQL the no SQL database paradigm is not appropriate for what you're trying to do because your data is too complex.
Yeah.
So I think the answer is if you have complex data, you want to use our relational database. If you have a lot of non-complex data, you're looking at a document store.
That makes more sense. I mean, even like when we've talked about the chasm stuff, it's not a complex model. We have users for the directory, and we have messages.
Right. And I think it can stay right where it is in a document store.
Yeah. But other than that, everything else about document data stores is just, to me, I just am not seeing. I like the ability to put constraints on the data, the columns, and the ability to specify data types better, and
right.
the constraints work to me very well, and I'm just like, I guess maybe what you were talking about earlier about not getting into it, but stored procedures, is that where you're going? Is that where you were going?
Sure, that's one place to go. Sure.
I mean, views. I mean, I think I went on a whole crazy love affair with materialized views because I had these queries that I needed to use on Postgres for analytical side stuff. And it was really painful to call those queries on the fly and get the data back. But I found if I pre-populated a view, which only needed to be updated like once a day for the purposes of who needed the data, and then I would just say, hey, refresh once a day, I had these completely denormalized tables that I could query without joins to get these reports. It was amazing. Right. It was just so awesome. And I mean, I was talking to my students. I was substitute teaching last week, and I was showing them like in MySQL Workbench, and someone was like, "What's a stored procedure?" And I was like, "Oh, it's basically the query I just showed you. It's already cached on here. Like you don't have to do the query. You just say, select all from this table by just calling that little stored procedure, and in a way that makes it so that you don't have to know SQL. You can just tell people connect to the database, call the stored procedure. You'll get the data you need. Don't worry about anything else." And I remember right out of college, there was a woman that her whole job was just managing stored procedures on a database at Budweiser or something. And she hated it. She hated it. But I was like, really? Like, that's a whole job? She's like, oh, you don't query the database with raw SQL. You always have to call something that I am managing. And so when someone comes up with a crazy query that's inefficient, it has to go through me. So they're using it as quality control on database hits.
Right. Which is an enterprise way to manage it. And I don't think you're going to have enterprise level document stores and except for really light level stuff. And that may be the answer is if you need 1 billion of something, go do a document store. Otherwise it's relational. Yeah. And it could be that simple.
Yep. The one side of it, and I don't know about, I guess I haven't really looked at it, but what do you have available in relational on the Google Cloud or AWS? Do you have to run your own server and then install Postgres, or does AWS have that now? I don't even know.
AWS has had that for a while. I'm trying to think. RDS. Yeah, they've had RDS for a long time. And you can, when you're running RDS, you can put Postgres on it. You can put MySQL, Maria, Oracle, Microsoft, any of those on it. And then just scale it that way.
And
that must be what we're using when we use Heroku, right? Is that's just passing off to RDS on Amazon.
Yeah, I mean, and then there are services out there probably using Amazon themselves, but they will give you a relational database that you can access. I mean, you're going to pay a subscription fee, but you could still use that. I mean, the thing that I like a little bit is if you're using a Firebase app, all the transmission is free as long as you're using it on the Google Cloud. So if your app makes a request on the back end, not the client, but on the back end, the app calls to a data store, there's no cost to that wire call, so to speak.
Right.
Now, going back to what you said earlier about the inefficiency of queries, like, hey, grab all the data you need and then filter it on your client side, that's still costly on the way that they bill some of these services, because they're going to say, hey, you're transmitting gigabytes of data every month, massive amounts, and you're going to pay for that. So your inefficient queries are costing you money if you do it that way. So that's one significant strategy you got to think about if you're doing that. But I believe both Amazon and Google basically say, if you have your app in our infrastructure and you make a call to a service, I don't think you pay for the bandwidth, so to speak. You may pay per call or something, but you're not going to pay for bandwidth if it's on that same platform. But if you build in Firebase, and you call Amazon to the RDS that you set up as your backend, as your persistence layer, I think you're going to be paying for bandwidth costs.
Well, and that's a concern. Is most relational database pricing is the size of the database.
Yeah.
And if you get outside that size, well, it's going to push back. I don't think this is a significant con for document stores, but the document stores could go on forever and you'll never know, but you're getting charged by each one. If I'm not mistaken, the way some of that is priced.
So anything else? I think I've complained enough about document stores and the cockamamie indexes and queries.
It was worth it's worth it. It's worth the work you're doing on chasms to dig in and understand. If we'd had this conversation 6 months ago, I'm not sure. I wouldn't have known the difference between Dynamo DB, Firestore, and MongoDB. Now I know that if I want any kind of featured document store database, I'm going to stick with Mongo. But I'm writing an Alexa skill right now, and they've got a really easy integration into their Dynamo DB. So I'm going to use it, which means keeping my models kind of light and not complex. But that fits what a skill needs. A skill doesn't really need a complex data model. So it works, and I'm glad we're finding places to use it.
Yeah, I mean, to some degree, I expect that we can trust that the providers will keep making it more efficient. So what we're finding out with chasms right now is we are like on Heroku, you have 30 seconds to reply to a request. On Slack, you get 3 seconds. On voice, the user experience needs really fast responses.
Right.
So we can't spend a bunch of time processing a bunch of data to give the user a response, because the user is expecting a conversation that with a device, and they're not going to have, like, I haven't seen it so far where the Alexa or Echo go, give me a second. It's more
right, for sure.
You expect a conversation where the other person is giving you back a reply quickly. So that speaks to a data store that is optimized for that type of thing. And everything on the Amazon and Alexa side is telling us use these tools. So that makes sense too.
Yeah, I question whether a non-complex relational database would be any slower. A non-complex relational database that's optimized for this use case, I don't think would be any slower. But that's not the direction we're going. So
yeah, I mean, I got it to work when I was using Rails to build that Alexa. When I was forcing Rails to be an Alexa app. Back in. And it worked fast because I was being careful about, like you said, limited joins. And I did denormalize the table so that the query that would come in and get the response quick. So,
and if you denormalize a relational database too far, you end up with a document store, right?
Essentially, yeah. But still, I still like it better. But
you'll have a better querying language for it.
Yeah, right. But what I did is I just did the materialized view of the denormalized. That's what I liked about the materialized views. I love the fact that I could create the transactional side completely in the normalized tables, and then I would create a materialized view that would represent the document data store side, everything merged together and denormalized. And that was awesome, because if I had a query that needed to be fast, I would just hit the materialized view instead of the joined versions of the normalized stuff. So that's how I was getting around some of those join query problems. And I was satisfied with it. I don't know if it works if you need, like, map views aren't going to work very well if you have to refresh the data constantly, because it's truly like you're rebuilding the whole thing. But
Right.
if you don't need the freshest data, and that's okay from that view, then you're fine. So anyway, that's what I got. Anything else on your side for how?
No, I think we could. I think we could complain about.
Okay. All right. Then we will find some newer technologies next week to get off our lawn.
Exactly. Let's go put the hamsters back in the computers and have them run the gear wheels for us and run this old kit technology. Maybe we'll find a VAX system or something.
I just want to go back to Lotus 1, 2, 3 because I think that's where it all began, and it's a time we return to the things that work, simple and clean.
All right, I'm going to go find a VAX system. You go find Lotus 1, 2, 3, and we'll meet back next week.
Sounds great.
All right, see ya.
Thanks for listening to This Old App. Show notes and previous episodes can be found on our website at www.thisoldapp.online. Reviews on Apple iTunes are always appreciated and help promote the show. For questions, comments, or things you would like to hear on future shows, please email us at hello@thisoldapp.online. Show music is Guns Blazing by Fab Claxton, licensed by Pond 5. Voiceover work by MeganVoices.com. You'll hear from us soon.